This problem is for you to try. Here's the same table that we used last time, but I added a row to it. I added a row that tells us the values of these functions when x is 0. And I've created a new function. K of x is the product of e to the x times f of x plus g of x. And I'm asking you to find k prime at 0. And I want you to label your work carefully so that it's clear when you're talking about k prime of x, the function, and when you're talking about k prime of 0, the number. So go ahead and pause the video, work that one out for me. Welcome back. Finding a derivative at a particular point, now that we've got some shortcut formulas for finding derivatives, is pretty much always going to be a two-step process. Step 1, we find a formula for the derivative function. That would be k prime of x. And then step 2, we plug in the number that we care about. So for k prime of x, I'm going to be using product rule. So my first factor was e to the x, so it's going to be the derivative of e to the x times the second factor, which was f of x plus g of x. Plus, and again, I'm running out of space, so I'm going to sort of toggle. We'll have e to the x, that first factor, times the derivative of that second factor, f of x plus g of x. Okay, so all of that's going to equal. The derivative of e to the x is just e to the x. And then I just copy that second factor. That's times f of x plus g of x. Plus e to the x times, in parentheses, and now this is just a sum of these two functions. The sum rule for derivatives tells me that's going to be f prime of x plus g prime of x. All right, that was k prime of x, clearly labeled. Everything was connected with equal signs. Now I'm starting a new equation for k prime of 0. So I'm plugging in 0 for x. I'm going to make a mistake. We get e to the x times f of 0 plus g of 0 plus, now I've got to finish this, but I've already made my mistake. I was supposed to plug in 0 for x. I'm plugging in 0 for all the x's. In this case, for e to the x, I have a formula for that function. So I'll evaluate it by using my knowledge of the exponential function. For f and g, I'm going to have to use the table. But when I plug in 0 for x, I don't just do it for some of the x's, I do it for all the x's. So then this becomes plus e to the 0 times the quantity f prime of 0 plus g prime of 0. All right, e to the 0 is just 1. Times f of 0 was negative 2/3 plus g of 0 was 5. I'm just going to write that as 15/3, getting a common denominator. And then plus e to the 0 is just 1 times f prime of 0 was negative 2 plus g prime of 0 is negative 6. Looks like I'm going to need to bump to the top of the board to simplify this. So let's see. 1 copy of negative 2/3 plus 15/3 is going to be 13/3. Negative 2 plus negative 6 is negative 8. So I'm adding, that would be negative 24/3. And so that's going to be some thirds. How many thirds do we have? Looks like negative 11/3. So notice our final answer is just a number. There aren't any x's in that final answer. Everything was an x when I was talking about k prime of x. Every x became a 0 when I evaluated at 0.